So, chapter 3 is current electricity. Okay, in this chapter, you'll be studying about the charges in motion. In first two chapters, it was under the unit electrostatics, where the charges were not moving, the charges were in static condition. So that the charges were not moving. So we call that unit as electrostatics. Now the charges starts moving, so we call it as current electricity. The movement of charges, we call it as current. Okay, the rate of flow of charge is current. So here the current charge starts flowing, that is current is produced. Okay, now what all things are there in this chapter? The first point in this chapter is, or the first topic is about the drift velocity. Okay, so that is a new term for you. Drift velocity represented using the symbol Vd. Okay, so if you have a conductor, for example, just assume this is a conducting wire. Okay, if the conductor is at rest, which is not connected to any power supply, which is not connected to a battery, this conductor is not connected to a battery. Now inside the conductor, the charges will be in random motion. One electron will go that direction, it will be randomly moving. The electrons will randomly moving in its own orbit. Now when that conductor is connected to a battery, as shown in the diagram, here this is a conducting wire which is connected to a battery. So the current will start flow from the positive terminal of the battery to the negative terminal. If the current is flowing in this direction, the electrons will flow in the opposite direction. We already know the current flows, or the conventional current flows in the opposite direction of flow of electrons. So electrons will flow in this direction. This is the negative terminal. So the negative terminal, the negative electrons will get the repulsion, and the electrons will get moved in. Electrons will get moved in this direction. That means the electron will get drifted towards the positive terminal of the battery when it is under the influence of a power supply. Here you can see, when it is connected to a battery, the electrons are getting drifted towards the positive terminal. One electron moves like this, another moves like this. It will move in this direction. The electrons will get drifted towards the positive terminal of the battery with the velocity, which that velocity we call it as drift velocity. Okay, so let us see the definition. Drift velocity is the average velocity with which free electrons drift towards the positive end of a conductor under the influence of electric field. That velocity with which the electrons drift towards the positive terminal of a battery. Electrons inside a conductor which drifts towards the positive terminal of a battery under the influence of an electric field. That velocity we call it as drift velocity. Okay, and it is represented using this term Vd. So that is drift velocity. Now next point is mean free path. Mean free path, that is actually the distance traveled by free electrons between two successive collisions. See, here I can say one electron is moving and it will hit an electron here. Okay, so that electron will get drifted like this. This is how the electrons move under the influence of electric field. Now, during this motion, see here two successive collision. The distance traveled by an electron between two successive collisions. How much distance is traveled by the electron between two successive collisions? That is known as mean free path. The distance traveled by the electrons between two successive collisions is mean free path. Now the third term is relaxation time. It is the time between two successive collisions. Relaxation time is the time between two successive collisions. Okay. So relaxation time is represented using the symbol tau. Tau is the symbol used to represent relaxation time. Okay. Now let us derive an expression for drift velocity. Okay. Expression for drift velocity. So we know F is equal to ma. F is equal to ma. Also in the first chapter we studied E is equal to F by Q. F is equal to Q1 Q2 by R square, and here E is actually Q by R square. So E is equal to F by Q, that we already studied, right? electric field E is equal to F by Q, or F, what I can write, F is equal to E into Q. Okay, if it is in case of an electron, we can represent this small q as small letter E, because E is the charge of an electron. Okay, so I can write this as E into E. Okay, so that is this. The electrostatic force, I can represent it as EE, where E is the charge of an electron and E is the applied, capital E is the applied electric field. So we have F is equal to MA expression is there, as well as F is equal to EE is there. So I can equate the RHS, both forces only, right? So I can equate the RHS of both. So you will get MA is equal to EE. From here I will be getting acceleration is equal to EE by M. This I am going to the denominator. You will get EE by M. Okay. Now we also know velocity is equal to acceleration into time, or acceleration is V by T, velocity by time, right? We know acceleration is velocity by time, or velocity is equal to acceleration into time. Okay, here velocity is equal to acceleration into time. Here the velocity is what velocity? Drift velocity. And what is the time? It is the relaxation time. The relaxation time, that is the time between two successive collision. So here the velocity is drift velocity and the time is relaxation time. So what you can write? Drift velocity is equal to acceleration into that relaxation time. You will substitute for acceleration. Acceleration is E by M into tau, where E is the charge of electron, capital E is the applied electric field, and M is the mass of the charged particle, mass of the electron. So this is the expression for drift velocity, very important expression. Okay, so that is about drift velocity, mean free path and relaxation time, and the expression for drift velocity. If they are asking drift velocity question for 2 mark, you have to write the expression also. You have to write like this and derive the expression. If it is for 1 mark, you can just write the definition and just write the equation. The derivation thing is not required. But if it is for 2 mark, you just write the definition and write the expression also, derive the expression also for drift velocity. Okay,